In this video, we will discuss sample size for proportions. Here's the formula for minimum sample size needed for interval estimate of a population proportion. N equals p hat times q hat times z sub alpha over 2 divided by e quantity squared. If necessary, round up to obtain a whole number. If some approximation of p hat is known, that value can be used in the formula. If no approximation of p hat is known, use p hat equals 0.5. This value will give a sample size large enough to guarantee an accurate prediction, as p hat times the maximum of p hat times q hat occurs when we multiply, when p hat and q hat are both 0.5. For example, a researcher wishes to estimate with 95% confidence the proportion of people who do not have a landline phone. A previous study shows that 40% of those interviewed did not have a landline. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. Since we're looking for 95% confidence, z sub alpha over 2 is 1.96. E equals 0.02, that's 2% as a decimal. P hat is 0.40 and Q hat is 0.60. Then N equals 0.40 times 0.60 times 1.96 over 0.02 quantity squared, which is 2,304.96. We round the sample size to 2,305. The researcher must interview 2,305 people to be certain of a 95% confidence and 2% accuracy. Suppose there was no previous survey done in the previous example. Find the minimum sample size necessary to be accurate within 2% of the true proportion. Since we do not know values for p hat and q hat, we use p hat equals q hat equals 0.5. E is still 0.02 and z sub alpha over 2 is still 1.96. Then N is equal to p hat times q hat times z sub alpha over 2 over e quantity squared, which is 0.5 times 0.5 times 1.96 over 0.02 quantity squared, and that gives us 2,401. So 2,401 people must be interviewed if p hat is unknown. This is 96 more than if we have the results of the previous study to work